Hello and welcome to the sixth video of the Introduction to IoT using NodeMCu video series. In this video, we will learn how to create an IoT project using NodeMCu. So let's give you a brief overview on what we will do in this project. We will upload the sensor data to the Thingspeak cloud and then we will control an LED using that sensor data. So we will use a DHT11 sensor and we will upload the temperature read by the DHT11 sensor to the Thingspeak cloud. And then we will control an LED using that temperature data. So we will set a threshold value of temperature, and if the temperature crosses that threshold value, the LED will turn on, and if the value of temperature is below that threshold value, the LED will turn off. So now let's discuss a bit about Thingspeak. Thingspeak is an IoT analytics platform service that is used to aggregate, visualize and analyze live data streams in the cloud. You can send data to the Thingspeak from your devices and create instant visualization of live data and send alerts. So we open the Thingspeak page and we need to create a new account if you already don't have one. So simply put your email ID and you'll be able to create a new account. So after creating an account, we need to create a new channel using which we will upload the sensor data to the cloud and also monitor the LED status. So we are naming the channel temperature and LED status. In place of field 1, type temperature, which will display the temperature as read by the DHT11 sensor on the Thingspeak cloud. In field 2, type LED status. In this field, we will monitor the LED status. After that, just save the channel. As you can see that the channel is created. Now, let's discuss a bit about the code. First, make sure that you have the Thingspeak library installed. If not, go to the library manager of the Arduino and download the Thingspeak library. Now, we'll include the necessary libraries, and here in the API key part, go to the Thingspeak page again. Under the channel that you have created, you will see an API key section. Click on that and you will see that you have a write API key. Copy that and go back to your Arduino code and paste it here. Now enter your network credentials here, and using this server constant, we are going to connect to the Thingspeak cloud. We are also declaring an integer variable called LED and defining the D1 pin to which we will connect the DHT sensor. Now, using this Wi-Fi client, we are creating a client that can connect to a specified internet IP address and port. Now, in the void setup part, we are setting the D3 to output mode to which we will connect the LED, and initially we are setting the LED to low. Then we start the serial monitor at the baud rate of 115200 and also initialize the DHT sensor. Now we are connecting the ESP8266 with Wi-Fi to the station mode and print the local IP address on the serial port using Wi-Fi.local IP. Now we are connecting the client to the Thingspeak server using Thingspeak.begin. Now in the void loop part, we are declaring a float variable t which will read temperature from the DHT sensor. Now we are again declaring another integer variable called LED underscore data, using which we will plot the LED status in the Thingspeak cloud. Now if the LED, now we are setting the LED value to the temperature value as recorded by the DHT11, that is LED equals to T. Now if the DHT sensor senses a temperature that is greater than equal to 25 degrees Celsius, then the LED will be turned on. In other case, if the temperature drops below 25, the LED will be turned off. Now this part of the code will run as long as the client is connected to the Thingspeak server. Now, this part of the code, the temperature and the LED status is sent to the Thingspeak server and the data is plotted on a chart which we can see on Thingspeak. The serial.print lines will print the temperature continuously on the serial monitor and it is put mainly for debugging purposes. Now let's discuss about the hardware connections. The DHT11 connection is similar to that already discussed, that is the VCC pin will be connected to the 3.3 volt of the NodeMCu. The data pin is connected to any one of the digital pins of the NodeMCu and the ground pin is connected to the ground pin of the NodeMCU. Now in the LED connection, the positive or the longer leg of the LED is connected to the digital pin of the NodeMCu using a jumper wire. The negative leg of the LED is connected to a resistor which in turn is connected to the ground pin of the NodeMCU. Now we upload the code on the NodeMCU board. Now as you can see it is uploaded, so we open the serial monitor. We can see the temperature output. Now open the Thingspeak cloud. As you can see that the temperature value is plotted and since it is still above 25 degrees Celsius, the LED is turned on. Now we have to wait for a while till the temperature drops below 25 so that the LED will be turned off. Now the LED is turned off as the temperature has dropped below 25 degrees Celsius. Thank you for your patient listening. Please don't forget to like, share and subscribe to our channel for further videos on this course. Thank you.